Hello everybody, welcome to another stream. How we doing? So last stream we got the sort of texture streaming in for the materials. So the materials now, as you get closer to it, the higher resolution texture will get streamed in, and as you get further away, it will sort of swap out to the lower resolution one. So we've proved that working by making sure that we fill in the levels of detail textures that don't get initialized or anything with that missing, that like the valve like missing texture thing, right? And so this is the 128 squared texture 2D array, which supports up to about 1024 textures being loaded at once at that resolution. But we can go through them and we'll find this is the 256 squared one. Here we go, right? This is where the current texture is loaded into. This is 512 squared. And as we move the camera, I can get the controls to work. There we go. So I've just moved it closer and it's probably gone to the next one up now. So it's cleared that one out. And then it's gone to the 1024 by 1024 resolution. So, so right now what we've got to fix is like, we've got to figure out, because we're building this material editor system, which allows us to like procedurally generate textures at build time, or in the editor basically through code. And we'll then store those out to textures, and those can run offline, they don't have to run with the game up. There could be a separate application which does it. And then we can obviously choose these textures when we build different scenes or whatever, different characters or models or whatever, right? So the thing we have to try and figure out is how do we texture this thing? So it's not just a sphere, right? It is an ellipsoid, but we're going to be using, we use the sphere projection though, because the ellipsoid could be any, it's just a stretched sphere basically. So, oh, there we go. So what we're going to try and figure out is how do we map a coordinate on the sphere. And I think the coordinate we're using is the surface normal in the local space of the object. How do we map that to a texture? Now, there's a few ways to do it. And right now we're trying the octahedral, and we're getting some sort of like seams. Now I do want to try and make this one work, and we'll go over the reasons why. So there's this classic spherical mapping. Texture mapping, where you take the spherical coordinates. So you take so with a sphere, you can represent it with a few coordinates, right? You can represent it with a sort of a longitude and latitude, if you will, a bit like on a map, right? Longitude, I forget which one it is. I think longitude is X and the latitude is Y. I have no idea. And then you have the sort of the radius, which is the Z coordinate. Now, you could do it that way, but the problem is you get stretching like this. Now I've got to go here because there's a chat up on the side and sometimes it's hard to see. Right. So you could do it this way, where you just take the latitude and longitude and then like just wrap it around the sphere. But the problem is the top of the texture gets incredibly. So when you take a sample of that point at the top, it kind of goes really fast over the top part, right? See this really old look. So the way you could fix it is you could do a sort of an inverse. You sort of can do an inverse of the. I'm not sure how they calculate this, to be honest, but it's basically like if you were to sample it, it sort of corrects the sort of glitches you get here, or the artifacts that you get here, right? And so Yeah, I guess you do some sort of inverse of the spherical the mapping or something like that. I'm not sure. But if you're going to do this, you need to make sure that you need to make sure that you have a lot of resolution. So you probably want to take the probably about 4 times as much resolution higher, and then do this effect on that, then downsample or something. Because the problem is this is really stretched, as you can see here. And what happened, or maybe more than 4 times, because look at that, that's probably just one stone that's just getting heavily stretched, or one of these stones, and then just placed there, right? So it just looks very blurry. And that's not very, doesn't look very nice, does it? So yeah, I think we shouldn't really use spherical mapping. So that's one of the mappings you can use. No, it's not the method I'm using. The one I'm using at the moment is octahedral, and I want to try and get this one working today. So this is one that has been quite popular for compressing. So when people do like light probes and they compress the light data into sort of this octahedral map. So a light probe is just a point that you shoot rays out, maybe across the hemisphere if it's on a surface, like this bottom one, or you've got a probe that's in the air, and you see therefore you need and you're essentially taking it from a sphere, and you're getting sort of like an octant of it, if that's what you call it, and then you're mapping that to imagine if you're sort of just making a sphere not curve anymore, and have sort of, and that's the octahedron, and then that gets mapped to just, it's 8 triangles, so it gets mapped to a 2D quad. So that's what we're using at the moment, but I don't know if the code I've got is correct. But I've heard things where if you sample on the edge, it's not correct, like the way it wraps. I've heard there's things to do with if you're going to sample octahedral maps, you need to repeat edge pixels or something like this. But then, yeah, so I want to explore sort of why I think I'm coloring in albedo like the normal, with the surface normal. So there's something either wrong with my conversion functions, or I think it is, because just look at that seam is just completely wrong, right? So even seams on the top as well. So we're going to explore a bit of the code we're looking at now. There's other ones we can do. Well, you could do a cube map, then you got 6 faces, and that's 6 times more memory. And yeah, there is another one called dual polaroid as well, which we could look into. Which is another one used for like environment maps and stuff. Hey Dixter, how's it going? How about a quad sphere? Ooh. Oh yeah, you're talking about the cube map approach, right? Is that right? Yeah, so you take a cube map, then you're mapping sort of like each face. Yeah. So this is the approach where all else fails, I guess. We go to this one. My issue with it is that we will have 6 sides instead of like a single. We'll have 6 2D textures instead of just one. But I heard this is the best for you get the least distortions or something like this. But yeah, maybe. Excuse me. What do you call it? Mapping. But yeah, that's the other way we could do it. So that's the all else fails method. But I'm going to try everything else other than that, I think. Or maybe we won't need 6 times as memory, but we'll definitely need 6 faces. Or 6, yeah. But yeah, so I do have a bit of a cold, so hopefully it doesn't ramp up while I'm streaming. It was a lot earlier, but it's sort of like calmed down over the last couple hours, so hopefully it's alright. I got a nice peppermint tea here, so hopefully it'll help out. But yeah, so where we're going to start with this. So let's start with like I've got a shader, right, called test material. It just outputs 6 different textures. One's albedo, the other one's emissive strength, metalness, roughness, height, and normal. So this is the texture that we've been generating at boot, and then sort of streaming into the to the material cache. As we get closer and further away from the sphere, we sort of take this is our proxy material at the moment that we're using, rather than taking one from a material asset which we'll be making later. So I've got this function called unpack octahedral, which I found on one of the shaded toys, and I think I translated it right. And so this will take a UV and then produce a normal, basically. And this will take a normal, then produce a UV. So I'm thinking the way the code is at the moment, so we need to care about is albedo. So all albedo is doing is, so I think we should we should max. Yeah, so we're taking in the UV, so it's just the pixel coordinate. And then we get taking the UV again of normal from that. And then that's the color. And that's it, right? So I'm going to try and max it with 1. Oh, so we're 0, sorry. So that we don't get any sort of negatives. Hey there, very much. How's it going? Wow, you streaming before me. This is rare. Welcome. We're just currently trying to figure out the best way to texture a sphere. That will also be used for ellipsoids as well. Because we keep making some materials. And we're going to try the octahedral mapping. Trying to get that working. How did the stream go? If you have any questions about the project, guys, feel free to ask away. It's written scratch from C. Sorry, in C. No libraries, basically. It got some single-header libraries, obviously. And no proper libraries that you're meant to link in or anything, other than stuff from the operating system. Of course. Yeah, the sphere. You just want it to be flat sometimes. You know, it's been a problem since world maps. Since we found out the world is a sphere. And obviously it doesn't need to look good being wrapped. Like, what's great about what we're trying to do here, okay, that's my missing texture one, is it doesn't have to look good when it's maps down into a quad. It just has to look good when it's sort of rendered on the sphere, which is great. Ah, damn it. I have a bit of a cold. Yeah, how did stream go? What have you been up to very much? How's Shame going? Yeah, so I think my first thing to check is, you know, am I? No. Okay, octahedral mapping. What I need to do is probably create something like this diagram here, where I can sort of see each of the triangles, and then I can be like, oh, this thing works, or oh, this thing doesn't work, right? That's the first stage thing. How do I write code like, to get that? It's like an octant basically, isn't it? You can tell based on the normal if it is positive, positive. Yeah, so you could tell based on... Yeah, we can write code for this. Shouldn't be too bad. So we take the normal... So we could do like colors based on... Yeah. So if we take... So our coordinate system is bottom left, near, right? So it's like, imagine graph paper, just like that. Ooh, sine vec3. That would be enough, wouldn't it, maybe? Yeah, it might be it. That's great. Man, absolute mathematician, very much. Axis chain stuff, right, I see. Yes. Yes, making sure it all works for loops and barriers and stuff. Yeah. Do you, yeah, and if you have any sort of like intrinsic things which turn into a pointer, and you have to sort of like, yeah, make sure it still works when you chain it. Right. Yeah, because I thought it was easy. Exactly. Yeah. Like, we never do anything. Like, if we knew how long or hard something is, right? We would never start. So it's all about going in blind, thinking it's easy. Then you achieve greatness. But unless you're Raymarch and you know a bit of maths, then yeah. Right, so with the sign, then obviously you can get some negatives in there. So what we need to do is... Nah, we could probably live with that, because I think it will colour it. It's been colouring like purple on that, hasn't it? I think. Let's just give it a go. Just gotta find the... Well, I can find the test one. Right. This looks incredibly wrong. Yeah, that's not octahedral mapping, is it? So, the normal... Yeah, something's probably wrong with the conversion function. So if we take... So we should get white on this side. And then... Yeah, the back... So imagine that's your Z. Yeah, so when would it be yellow? But yeah, we should be seeing way more than this. You know what it is? It might be in signed norm. We're probably seeing this. It's in signed norm space. We're seeing just one quadrant of it. Got it. So this unpack octahedral thing. What I need to do is take that UV and I guess, right, I might need to do something like this. And then add 0.5. Wait, or was it the other way around? Sorry, I need to get it to sine norms in it. So it's the other way around. So it's times 2, take 1. So from 0 to 1 to minus 1 to 1. Let's try that, see if it improves. Right, that's looking more, I want more colors. So let's see what. Right, that looks better, doesn't it? Obviously, it's for your smaller MIPS, we can zoom out a bit more. Yeah, so we're clearly seeing this pattern here, which is great. So that's cool. We're just going to make sure the mapping now is when it goes the other way around. So I think this one also needs to do because I got them from the same place. So I think we need to although we should really inspect the actual. Yeah, that looks painfully wrong, right? So we should be seeing a sphere like this, basically, where you're seeing like octants, if you will, if that's the right terminology. So I think then I've got to make a thing called UV. And then I say UV equal. So add S UV 0 mol S. So I'm going from minus 1 to 1 to 0 to 1. Oh wait, what am I doing? Yeah. I feel like this whole thing can be done without if statements. What's an area up? Because the whole z coordinate thing can just be treated as an offset and then put a fract UV afterwards. Right. Oh, that would be great. That'd be awesome. As an offset and then just put fract offset. Yeah, but the reason why you do this yeah. But fract means you have to do a mod operation basically, isn't it? Whereas this you would do a select instruction. I don't know what the difference would be. What would be better? Oh, that's alright, isn't it? There we go. Look at that bloom. It's a bit much on that white side. This garden thing before the comma. Where before the comma. I have no idea. Could I send you the code very much? And you let me know what you're saying. Well, let me figure out this. So go. The pastebin.com, there you go, whack that in there. Here we go. You need a break, alright. I'll put it in there anyway, just in case. No stresses. If you want to go, feel free. Appreciate the raid. Have a good evening if so. Right. Alright. So, we've got the oxygen mapping code corrected now. So, now it's just a case of, let's bring back what we had before. And look at that, so it should be sort of a smoother gradient. Rather than a sort of a clamped gradient. Clamped normal, if you will. Right. That's looking okay. I heard things about we would see seams. I see a seam right there, can you see it? So yeah, I think we need to repeat some pixels. Like an edge pixel or something like that. Because I've heard things about sampling these things, you get seams. So if I was to zoom out more... Oh yeah, we've got to do proper MIP selection as well at some point. But yeah, you'll still see the seam no matter what zoom, basically. Now I wonder where the seams are. So that's the window a bit bigger. I think we can turn off bloom for a second. Just to sort of see these things better. So there's one big old seam there. Have we got another one here? No. Does it go all the way down the middle? No, it doesn't. So... Right. So let's... I think it's all the way down this side. So we take the absolute. Oh, did we take the absolute? Right. But if you take the absolute, then you'll get... It might fix the seam. Let's have a look. Yeah. We could... We can maybe turn this into... From -1 to 1 to 0 to 1, so to unorm. N 0.5 F 0.5 F. So that might be better. So we'll see the negative side, but we still might see the... Okay, we still see the seam, which is what we want. So let's take a look at that texture now. And we'll get rid of that bloom. Yeah, so this has like those triangles basically, and we're seeing a seam somewhere. We've just got to figure out where. So it must be at these edges. Okay, thank you very much. Okay, so we can toggle this. Let's turn off bloom as well. Yeah, I don't know what's going on there. Ah, it's too long. Right, so bloom's off. So we're seeing a seam all the way down, and why is this still dark? Right, because the lighting, isn't it? Okay. Anything we can do about the lighting here? If we boost up the light intensity, it's not going to really help, is it? It just makes it really bright from one side. Excuse me. Right, 2 secs. Okay, so right, I think we need to put another light this side as well. If we're going to see this seam thing properly, I don't know. Or we could rotate the seam. Yeah, we could rotate the object around the x-axis and get the seam facing up top. And that would be better, I think. So that would be in the graphics code. There is a where we find or load a model. So the quaternion we need rotation, or the axes is along the x, and the angle would be, it's just a quarter, right? So pi gets you halfway around, so half pi. And that will rotate it such that it's facing, the seam should be facing upwards. We should be able to see it better, I think. No, so we did it the wrong way around, so the seam's all the way at the bottom now. And we should be able to tell if we just move. Yeah, you can see the seam starts here, yeah? And it goes around there. So we just need to do negative pi. And that'll get it going, seam on top. Okay. Beautiful. Well, not beautiful, look at that seam, it's horrible. So if we can fix that seam, then it should... Then we've got to maybe look at... Oh. How far does the seam go? Right, it's not visible here, is it? Okay, so it's on this side. So if we open up the texture viewer now, we can kind of see what's going on, hopefully. So we're seeing some yellow here at the pole in this example. Right, so the yellow's at the pole, and the yellows is sort of all of these edges here, right? Now, we've kind of got like a blue... It's probably this triangle here. Like a purple there. I don't know, it might be better to get the old one we had before. But so the seam is when this... I don't know, where's the purple? Why is the purple on the purple? Oh, excuse me. Oh. Alright, maybe we just need to do the rotation a bit more and get it all into the light. I don't know what's going on. Let's find the seam again. Here we are. Is that where I wanted it? Yeah, we see the seam. Let's turn off the bloom. Oh, there's two seams. Ooh. Oh, there's another seam there. There's seams everywhere you go. Okay, so there's always seams. So these... Okay. How far does that seam go? Up to here. Right, so there's a cross point. Okay. I know where the seam is now. Right, so the yellow bit is at the corner. So this is what... Okay. So I've heard what the problem is, but now I get to kind of see it for myself. So the pole is basically like each of these corners here is where that top pole is, yeah? Crap, where's that window gone? Oh, of course it's here, right. So this yellow region here is where that's the pole. I've just rotated it, yeah? So so we've got a seam going so purple. So what's causing that seam? So the purple's all here, right? If I were to sort of get the triangles, maybe we need to like flick between. It'd be nice if we could flick between the view mode that we had, where we could see this sort of like pattern on it again. We had one a second ago. Maybe we should get that going. But yeah, so there's sort of a pinky color here, which I would... So the purple bit that goes into yellow, there's quite a few of that, isn't it? Right, let's get that. Let's get some code which will like get it to always copy what's from the texture, and then we'll make it change every frame or something. So let's just go. No, sorry, every so many frames. So we'll do like a if graphics global time in seconds. If that is so we're trying to say like, I guess we could turn it to an int and then mod that with like 10 and just say if that's less than 5 do this one. Else n equals sine. Right. And now we're just going to make sure that the texture or the material cache system, make sure that constantly tries to update the LOD. So where do I find that? So it's going here over all of them. If it's ready, if LOD is not equal to this LOD, so I think we can say all one and just get it to always fill invalid, then load the material in. And so that means it should constantly update now, and it doesn't have to change LOD. Well, I don't see it change. But if I go to the texture viewer, oh, okay, it's because I'm not calling it every frame. Test material. I need to call this every single frame now. So we'll copy it. We'll copy it to the frame start. Put it here. There we go. Oh, did I not do the down sample? Crap. That's why these are all here. We need the down sample as well. Right, so now that runs every single frame. Then every 5 seconds or so. I'm not sure what the performance is. That's alright. Then it'll flip. There we go. Good. Great, so now I've got a chance to already see what's going on. Every 5 seconds it's going to change. And we get to actually see. So there's the seams. Right, so it's between the red and the black. This seam. So let's take a look at that one. Right, red and black. Right now, obviously it will be this side here. Interesting. It's looking so white. What is causing it to look so white? Let me take off the bloom. And then all the lighting as well. Take off the tone mapper. Yeah, let's take off the tone mapper again. Okay. So we're seeing like a bit of a yellow. Right. So we are doing sRGB here from linear to sRGB. But anyway. Okay, so this edge here is where it happens apparently. Oh, thank you very much. Have a look in just a minute. So that obviously mirror repeats onto, or repeats around onto that, right? It's not mirror repeat, it's just a standard repeat. And this one repeats onto that one there. Why would you get that seam? Kind of, it looks green there. Oh, typo. Okay. Thank you. Right, so I guess it's when it calculates the normal and it's sort of... Is it caused by the sampling or where this... Because it seems like it would just get in there a bit more. That line, right? Green, yellow, interesting. It could be just the code which translates it into a... This has a bit of green and yellow in it. So it must be when they meet... Oh. Maybe I need to just, take a screenshot of this and just repeat it. Hey Dora, how's it going? Yeah, unfortunately not for sale. I don't have any NFTs for it. So yeah, my apologies. How you doing though, Dora? Hope you're doing good, sir. Yeah, I've changed my sign so it doesn't do that. I used to have that behavior, but I changed it. Is yours returning 0? Oh wow, amazing. Custom diagram for me. Appreciate the work. Oh, okay. Yeah, fair play. Should try to get back to sleep, man. I don't know how you haven't. I know you wake up early, isn't it? Because it's morning for you now, isn't it? Right. I see. Yeah, it's always difficult for me. I wake up early in the morning as well, and I struggle to get back to sleep again. The only fix I have for that is go to bed earlier. Yeah, I struggle with that too. I don't struggle going to bed though. B basically pulls them apart by the R multiplied by sine. Right. So V is right. R is there the radius, right? Interesting. Right. Right, that's the coordinate. Oh, that's the normal. And the radius is that. Right. Roswell frameworks, man, if I don't have to do with it, then I'll be on the hay. Oh, wow. People do web stuff in Rust? I know people are trying to do it, but I didn't realize people actually do it. Right, okay. 2 seconds. Got a bit of a cold. Right, so UV plus equals Q plus R sine. Right, so you do that one or that one. I see. Right, that's clever. Oh, okay, but that could also just be a fract. Right, so fract is just mod. Yeah, fracts will just give you the bit before the decimal place, basically. So you're... Right. Oh no, so you're going from... And then you fract it afterwards. Right, so it will then just wrap itself back into here, I see. Right, I get it. Yeah, I don't know why. But then maybe that's because it becomes... So you don't... Let's have a look at it. Hey Alex Void, how's it going, sir? Oh, my days has been an absolute raid. How's it going, Alex Void? Appreciate the raid, sir. What have you been working on? Appreciate it. We're currently trying to map a 2D texture to a sphere, and we're currently doing it with the octahedral mapping, and we have a seam. Bum 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 bum. So just trying to fix this seam, and also very much is telling me about how to make the code better. But yeah, hope everyone's having a good day. We're working on a custom engine, custom game without an engine, but it's kind of ended up being the other way around, engine without a game. But it's just basically rendering a bunch of ellipsoids and spheres, and we're just trying to figure out how to texture them at the moment. So any questions about the project we're working on, feel free to ask away, guys. Yeah, having a good stream, man. Have a good stream. Hope you had a good stream. Welcome, Raiders. And okay, so yeah, so Raymarch was saying, right? There's like a... So rather than doing that sort of... So he's talking about going into a... From a sphere to the octahedral layout. So he's saying... Right, then he's saying just basically you need to fract. So it's... Where is that code here? I don't see this here, so it's R. Ready to be the Z. Sine. Where are we doing the sine anywhere? Right. It's here. Eh. Right, it's all the tenaries, right. Oh, with a Z. Oh, so it's just this one then. Right, so you're saying we could just fract that. But yeah, I'm not sure. Because this might be better. I'm not sure though. It just depends. I've not tested it though. Probably quite negligible as well. Because the problem is a fract would be like, be a mod, wouldn't it? If it'll get there. So a floor and then a takeaway. Right. Right, I see. Yeah, I'm not sure that would be like... It might just be better to just do a select statement. Because that'll just be a select in the end, I think. Like a conditional move. But yeah, that's the idea though. That's cool. Right, so let's fix this seam. So I'm trying to think like if I take this and put it into Krita, if we mirror it ourselves manually. It is a single thing in SpearV, but I don't know what that actually translates to in hardware. If you check the AMD ISA, AMD RDNA 2 or 3 these days. I don't know if you have a sort of a frac. They probably have a floor. Do they have a floor? I'm not sure how they do floor on. Yeah, they have a floor instruction. What about a fract? Look for frac. Oh, they have a fract. Yeah, they got a fract. Vector fract. And they couldn't use the word fract though, because that would be an abomination. But yeah, let's try and mirror this thing. So, what? Mantia listing going to town. Alright, so we take this. Let's manually mirror, like actually do our own sort of like, oh my days. What's going on? Oh, screw it, I gave up, give up. Right, we found an edge. Oh, it's just, there we go. All right, we got it. So, perfectly selected texture here. Now let's figure out what happens when we, Right, let's cut it. Yoink. Give the move tool, give it a good old paste. 1. Oh, why is it blurry? It feathered it. I don't know. We'll see how it ends up. Well, okay, it's not feathered anymore. I don't know what's going on. Right. So now hopefully we see what's going on. So does this seam here is the question. Get this. Huh. Right, zoom out a little bit. So there's one triangle like that, and one side of it's got the yellow, and the other side of it's got the purple. Right, so red. Interesting, one side has the yellow. So that would be the bottom piece here, right? And that'll get yellow. And that has a seam, right? That obviously has a seam as well. What does that seam look like? What color is that? Seems not so bad there, but it is present. So you've seen this sort of red carry on here, strange. Because you got them all joining here, and then for some reason it sort of like gets a little bit of this one on the edge, which is bizarre. Right, so there's one texture there, so 2, 3, and 4. And this is where they sort of repeat, and you get this sort of cross section, and they should. So you're getting like a sample. They're also square as well. At powers of 2. So and it's a repeat sampler. There's samples over the edge, and it should just grab these pixels up here, right? And right. I think I got an idea what's going on. So these pixels. Right, it might be to do with the way. So what we might be able to do is, if we take the mouse, we can see what the normal looks like, maybe. And see how the normal behaves as it gets to here, I guess. Or the UV. What would it be? Oh, music has stopped. Yeah, so it's strange. Very strange. So on that edge, maybe when you've got a normal there, it's probably the way it's getting translated into that space is it's a little bit incorrect or something. We'll see. There was something wrong with the seams that people would say online, but I can't figure out what it was. Okay, let's have a... Let's get some debug stuff going. So, in the code where we do the rendering, we want to save the pixels there. Yeah, my mouse is over that pixel then. So that'll be in calc surface color. Okay. So we calculate the UV here from the normal. So what I'd like to say is, if we don't really have the coordinate coming in here, I don't think, the UV is the right, let's take these two things here. And let's find the, so I think we're doing it using the shade the visibility buffer shade 1 at the moment. It's here. Excuse me. So right, let's make another little variable called n. I'm going to say if mouse, or is mouse at, and I think we'll say equal, something like this. Then we can print this out. So we can say GPU hprintf n equals f, and then uv equals f and f. So then we can just simply just do n.x, n.y, n.z, uv.x, uv.y, and see that printed out in the terminal. Hey, that suggestion with the F key, Felix, was really nice. Found a plugin for NeoVim that does the same, and it's been super enjoyable to use. Awesome. Yeah, yeah. In Helix, it's default mapped to like GW or something like that. But yeah, mine's on the F key. It's handy. I often actually forget it's there, and do some other silly motions to get to where I need to go. But it's pretty good. That's great. Helix making NeoVim better. Right, so unfortunately I've got to... Right, so see how this thing behaves. So as we get to the seam... So I guess we're saying, is it smooth, right? So what are we traveling along here? This is the x-axis, isn't it? Let's get in there a little bit more. Right, so it's like that red. So it's not sort of jumping until it goes across here. So, yeah, so at the edge of that red... Right, the Y goes down. So it's for UV, it's the Y that causes it to change, I think. Yeah. So it's the Y that causes its flips. Let's take a look at that. I'm confused. Y axis, this is the X axis. Why? This should be the X axis. I'm so damn confused. How is that getting... So we go across the X here. Like... Why is that increasing in the Y axis more? Have I done my printing wrong? X, Y. Huh? It's essentially doing divide by zero, they're just not sure what's in the code there. That's a good suggestion. Thank you, Pete. I'll look into that. Yeah, it's a good idea to look at. Yeah, set packs, procedural. There is a divide, right? Sum all elements, absolute. Right, maybe. Do you sum all at the seam? I don't know if you get a zero though, but maybe. Right, it's that normal if you add all those elements up. Yeah, it's not a divide by, you won't get divide by zero, so add sum the absolute of all of those. Yeah, that's gonna be more than. Yeah, so that's the only divide going on in there. But that wasn't a bad suggestion though. Right, so it's not that. The bit I'm confused about is when you go across. You know, let's stop it doing this flickering thing. It's kind of annoying. Let's go back to the. Yeah. Let's run that again. And we'll take a look at these numbers a bit more. Right, so the seam is around the other side where the light is. I heard something where people say you just need to repeat the pixels, but I don't understand why you need to repeat the pixels, because surely if it's repeating texture, like, oh crap, I shouldn't have done that. But anyway, if we do a count surface, we're using the sampler, which is a repeat linear sampler. Let's just double check that. So that's in GPU, repeat linear sampler, so it's using the repeat address mode, and we see how that gets down in the Vulkan layer. So repeat address mode is just repeat address mode here in Vulkan, right? And you see it gets used when the samplers get made, right? So I wonder if it's anything to do with linear. What about it? Yes, it does the linear, the bilinear sample, right? So it's going to mix the pixels, right? So, but you don't see it here. So why does it fight between being like a linear sample between black and red is not going to get you green then yellow, is it? This is something to do with the mapping, right? Hey Geeko, how's it going, sir? So red is here, black is here. I assume, right, it's repeat. So if you go off the end, it's going to repeat to this side. Then for some reason you get a bit of yellow in there, going across the whole edge, and you get a bit of green as well. I'm not doing bad, thank you, Kiko. I'm just trying to solve this sphere mapping problem here. We're getting close though. Texturing this phase and the octahedral mapping is hopefully it's going to be cool. Got to try and put proper texture on it, but I'm doing alright though. You know, a bit ill. I kind of was fine yesterday. I went to the gym, had a really good time. My wife did some running, and I, you know, used the machines and everything. And then we went to the steam room, and when I came out of the steam room, I was feeling like, you know, proper like. Maybe the term is like, yeah, just feeling really good, right? But just drained at the same time. And like just everything had just been completed, you know what I mean? Just and then you know, by the time I got home, I was just ill. So yeah. So I'm a little bit ill. But the show must go on. Can you see the function? Yes, sir. So you're taking the normal. So you take the normal xy. So in our case, to see some of the parameters, what they are, and you're summing all of the absolute of every component in the normal vector and then dividing it by that. So if we take this here, so the type of normal we're looking at here is basically x is basically around 0, and yeah, the other ones are. I honestly don't know why. Oh, that's interesting. The y. I don't understand why the y-axis. The I am doing this to it afterwards though, isn't it? Not the problem. See, this function before here gives you in the center of, it'll give you inside norm space, wouldn't it? So it'll give you a point before this conversion here, it gives you inside norm space. Maybe we should try and get a color. Maybe we should put the result into a buffer and then read that and actually view it in the texture viewer. Might be a bit of fun. But you can kind of see, maybe see what's going on visually on the texture. Yeah, we could do that. So that shouldn't take too much work. Yeah, it does. So I think we can basically just poke into globals, or just poke something like a test UV into there, like that. Right. And then what we can do is, well, not even that, just say, test UV. So in graphics, internal shared, I'll find my global structure, which is shared across all shaders. And I just literally just making one in the persistent space, just call it test UV. So then, in that test material thing, which runs every frame at the moment, generates that texture, we should be able to just say, okay, get what's known as a test pixel, or test coordinate, and we'll say, right, that is, it'll be the inverse of this, right? So it'll be divide, then multiply, then take away. So multiply to sub first. Right, E32 times 2 cast. Sub 0.5 after we multiply. Oh crap, keep in threes. A global test UV with, oh crap, with the dims of the texture casted into a float, then we're subbing half a pixel. Right, now we're just going to say if it's in the neighborhood of being, well, I maybe didn't have to do all of that. Maybe. Yeah, it might have been better to do this instead. We've been sort of like test. Right, I got a better idea. Test radius. So we'll say, let's say it's like, you know, I want it to be about, let's say 8 pixels, because it can get quite big. And then all we're going to say is probably .x, right? And that'll be good enough. And then we're just going to say if test radius is it's got to be wrapping though, isn't it, really? Do you know like where exactly the problem, if not such end results one by one until you get your thing? By the way, what's the thing that keeps showing in the bottom right? Oh, it's just helix, right? I don't know, like, yeah, it's just the helix's sort of suggestions and stuff. The exact problem is we're just trying to, we're getting a seam where we shouldn't be getting it, and it's on when it wraps, there's a repeated sample, and for some reason there's a seam. I don't know why there is a seam there. Doesn't seem to make sense why there's a seam. I think it's due to the way the mapping function works. Test radius. So if we take the coordinate, or the EV, sorry, we do a takeaway. So it'd be a sub with the graphics global test UV, the one we set based on the mouse pixel position. And we're trying to say, right, take the length of it, and then if that is less than or equal to Now the problem is the UV can... It won't go... Problem is it won't go near the edge, that's the problem. Let's just see how it looks. It might give us enough information. It won't wrap around the edges, but it'll be hopefully good enough. Then n equals negative of itself. Yeah, so now we should be able to see it in the texture viewer, the thing that we're pointing at on the screen. So let's get round there, and we'll be able to see a nice inverted cursor that scrolls across the texture. So, oh, I'm actually seeing it on the texture itself. Look at that. I didn't expect, of course, you'd see it show up here as well. But yeah, so maybe we need to get the repeating. Maybe we need to get the repeating code working for this sort of point that we're looking at. So right, here we go. So now we're seeing this thing sort of move. Oh, so it is actually going around the bottom of it. Oh my days, are you seeing that? Right, so that y coordinate is correct. Right. So as you can tell when I'm going over this bit here, it's down in this lower side here and this side here, right? So there it is over the red, and there it is over the black. So what we need to be doing is we need to get an edge of red pixels down here, and then an edge of black pixels there, right? And then we need to get an edge of... Okay. So that's the this is the problem with the octahedral mapping, is that you will need to either have a bit of maths code which will account for this, or you repeat the texture data and make it... You basically have a border, right? And then the wrapping... Oh wait, is that, will that work? Yeah, you can only put the edge pixels there if you actually sample it differently as well. You've got to reduce... Yeah, so if you're gonna repeat the edge pixels, you've still got to change the sampling code. So maybe there's a way to change the sampling code. Right, that's not good. Let's see how people have solved this on the internet. Octahedral mapping. Crying out loud, get out. Right. For GPU dynamically generated data structures... Oh, it is. Close that for a minute. Right, so know the problem now. Let's see what this is saying. For GPU-side dynamically generated data structures which need 3D spherical mappings, two of the most useful mappings are cube maps and octahedral maps. This post explores the overhead of both mappings. So this is just a performance thing. I wondered... Hey, it's done by Timothy Lotzer. But in terms of like... Does this do the repeat thing? Has he got... Right, unfortunately GPUs don't have octahedral wrap mode. However, the mirror repeat can be used with some VLAU work to emulate. Right, yes, there is the mirrored repeat. But check for offset over texture edge. Example of computer mirrored repeat sampling of an octahedron map with a small text offset. Note that this is not designed to solve the double wrap case. Right. But if we mirrored repeated it, would that solve the problem? It might do it, right? Because you got a mirror repeat sampler. Let's try it out. So let's just change it in the Vulkan code, the GPU code. So we'll just change repeat because I'm not using it for anything else at the moment. So let's change it for mirrored repeat. I think that's supported on everything. I've not seen it be a feature. But that was a GCN thing. That blog was sort of back in the day, so maybe this is now a thing. We could just use mirrored repeat. Right, it seems to have gone, the problem there. Oh. So just you use mirrored repeat and it works? Let's check if the other seam is... I can't see a problem with the seam there as well, that's good. So what about this side? Well, these are not a problem because they're not on the edge. Whereas these are sort of mirrored, if you look at the texture viewer again. Okay, that's good. So you just use the mirror repeat. So yeah, these are where the seams are. Because the way the octahedral map works, the repeat, yeah, it's different. Yeah, that's good. Awesome. Yeah, because we're only sampling up until there, and then the coordinate gets remapped anyway. So it just needs to be a mirror of itself for now. So technically it should probably grab the sample. Yeah, so it's probably technically wrong, right? You're grabbing the same pixel again when you're at the edge, basically, right? Because it's a mirrored repeat, rather than the one from the other side. But it's probably not a big issue. Yeah, it's probably not a big issue, it's just slightly wrong. So then that would mean we could... Yeah, so I guess let's do a proper mirrored repeat and then we'll bring... Actually, no. Yeah, let's do a proper mirrored repeat. No. So we'll bring back... Let's undo some of this code now. We don't need it there. And then we have that sort of like timing code as well. Right, here's that timing code where it... Oh no, you'll get that flipping code, don't need that anymore. Excuse me. Right, maybe the problem will reoccur if you do it with a proper image. Maybe, actually. Maybe not. Yeah, we'll try it out. Why not be like Why not like the triangle sphere? The one you make out of a cube, and then you create a texture like a cube map. Yeah, so the problem with that, Geeko, is that would mean I need 6 faces, or 6 different textures, one for each face of a cube, which I could do, but I would like to cram it all into a single texture, and that's what the octahedral map allows us to do. But there might be some weird distortion things, or you know. So hopefully this should be less texture space taken up, basically, doing it this way. It should be good. So we don't have to update every frame now. Let's just do all of that. So this is now just not the normal being put on a sphere. So hopefully we don't see the seam there anymore. Yeah, we don't see the seam there anymore. So right now. Awesome. I think that'll do. So let's get the proper mirrored repeat. So there's another seam along the X. I don't really see it there either, which is good. Cool. Right, so that will do. We've got to try and have a play around with this. So we've got some other things we want to do today, but I think it'll be on Tuesday's stream. We want to actually try and generate a nice texture, maybe a couple, because I would like to see, test it out before I go ahead and build an editor. Like, what can we procedurally make if we actually tried to make something, and yeah, how well can we make it look, basically. So I've got some ideas for that. Material plan, down here. So basically ones like wood, like a bark or planks, or like this one will probably be a fun one. Maybe we start with this one, like a volcanic ground. Like that sort of, like, you've got sort of lava in between some cracked ground. I reckon we can do, use some sort of like noise to form some of the sort of the ground quite easily, and then it's just a case like this. Basically, we can use a certain noise, I forgot what it's called now, to form a ground kind of like this, and then just have a radius around the edges that's controllable to sort of change how big of a gap you want between the rocks, and then just try and shade that. And this could be emissive as well. This is why I wanted to do it, because this bit could be emissive. And it'd be interesting. So yeah, maybe we'll do that on Tuesday, have a bit of fun, try and make something. But on today's stream, what else I want to do, after we've done that mirrored repeat thing, is we've got to properly calculate the MIP level. So we've got issues where, if you, like currently we're streaming it into the material cache for the closest resolution. The closest height of a sphere, and we're sort of like taking that and we're rounding it up to the nearest size of a power of 2, and then we're grabbing that level of detail and streaming it into the GPU for it to use. Now, if you have a sphere which is really far away, we're only using the closest MIP level right now, so we've got to try and calculate the correct MIP level to use when we sample the texture. So we'll set up an example and see what the problems are in a bit. And we might do... Yeah, we might have to make another test one. But yeah, hopefully we'll get that done today as well. So I think we've done the mapping thing, which is great. So we want to try and go back to GPU and add the mirrored repeat. Now I think these are supported. I didn't have to add a feature, right? I think that just comes standard these days. But anyways, just live with that. Works on my machine. Now GPU.c. So we just basically want to repeat those. They mirror repeat. Okay. And so mirror repeat. So it's mirrored in Vulkan. There we go. Cool, 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 cool. So then all it takes in the shader is when we do that calculate surface color, we need to use the mirror repeat. Now I need to actually put this in the global structure, so where we have those samplers. Oh, mirror repeat, and then in the graphics code when we upload it, and then that should run with no problem. Makes sense. By the way, how hard would it be to make HTC to debug, to do debug info? It already does basic debug info, I think. But what application are you speaking about using it in? Like is there a debugger, GPU debugger that you're thinking about? Yeah, I forgot to do debug info. No, maybe I don't make it output line. I forget. I've done structures, debug info for structures, but maybe not for not line info. I think that's what I've done. Yeah, so yeah, there's no line information, but there is names and stuff that I've put in there, debug. Now I've tried to use it with the NVIDIA shader debugger. I was playing around with making GPU hardware debugger for RDNA. Oh. Oh wow, cool. Wow, fancy. That's awesome. Yeah, because they've got the spec that's open. So are you sort of making a sort of software emulator for RDNA? Is that what you're doing? And then it obviously debugs the code. But yeah, so the debug info is only for the data types, from my understanding. I forget where it is, what instructions you put out. Oh, no. They are decorators, aren't they? They're like a decorator. Decoration. I don't know what they are. Forget. Yeah, spivvy.c debug. No, spivvy. There's like a name thing. Add name. Right. Op name. Right, yeah, so I've got the op names out for types and member names. So yeah, the types have names and so do the members. So that shows up in the debugger, but there's no source line information. Oh. Well, the GPU can do trap and stepping. Really? How? Yeah, but how do you interface with that? Like in a Vulkan code base? How are you able to sort of get that to work? Is that through like a kernel driver? Like, how would you do it? Yeah, in terms of how easy would it be to add line information to HCC? Well, the line information is already there. It's just figuring out how frequently do you sort of emit the instructions. So it probably won't take too long to do it actually. It's just figuring out how to do it. There you go. We're not getting sort of mirrored repeat things here anymore, which is great. Cool. Sorry, we're not getting the seams anymore because we're using the mirrored repeat thing. Right, so let's go back to here and change that rotation back to identity quaternion. Right, so all the temporary stuff we put in has been undone, I think. Right, looking good. So the next thing to do would be trying to get that MIP level sorted out. So what we want to do is actually see the potential for this be does it have something like, yeah, the programmable break, like a halt or something, yeah. I don't know if we'll be able to test it like this, but I think what we want to do, maybe we need a better texture, and we need to say, you know, so across one axis, so let's say the X. I want to only put 2 ellipsoids out. I want to put out... Ugh. Maybe I'll just hard code it, right? Maybe do a +1 and just throw on. Yep. All right. Just throw on another one of these. This is cool. My idea is to modify radv, and then when you run an application, force it to use the modified radv version, which has the trap handling, upload interfacing with the kernel, something like this, or maybe skip radv. Try to get some sort of prototype next week. Awesome. So radv is the kernel driver, isn't it? Yeah. But how would you skip radv entirely? Yeah, that's the... Yeah, not sure how you do that. User space driver that implements Vulkan. Oh. Oh, so all you have to do is get it to emit the instructions for the RDNA. Okay. For the RDNA. Because it is in the manual. Right. So RDNA 3 or whatever ISA. They have the instructions in there. So what you're saying is, let's just emit those and see what happens. Right. And upload a trap handler, right. Okay. Yeah, I haven't read it extensively to sort of understand what goes on. But yeah, right, okay, that makes sense. You've got like a trap signal or something like that that you can... Right. Interesting. Yeah, so you've got to somehow like hijack it to emit. Yeah, I don't wonder how you'd do that without changing rad view. While in the trap handler state, so it's going to be written to. Okay. Yeah, I wonder. No, how's the point of the current trap handler program? Right, so the trap handler program would just be some more instructions that will... I don't know what they would do. Oh, it'll allow you to like step on that, maybe one more line or something like that. By reading it from a buffer or something, right? Yeah. See, I guess you communicate over a memory address or something. Right, fair enough. Sounds pretty cool. I like it. If you could make it somehow work without a custom driver and then somehow get it committed back into some upstream thing, right? That would be awesome. You know, we need to get proper access to these things. That'd be cool. Alright, so I added a 1. So I think I can just basically like put it a 1 there, so it's the second one, and we're gonna do it from, so it's got to do a bit of maths here, and 0.5s, then divide by that. Right, so if we just plug in, so if we go x, let's put it along the z, so 0, 0, I'll divide by ellipsoids count. Right, I want it to just be... Wait. Why am I doing it in the model space? Why not just spawn another model? Silly me. Right, where's the models? Right, here's the test models. Right. Add 1. So translation 0, 0. And then we probably want the other one off in the distance at something. 50 might be a bit too far. Maybe 30 might be alright. Alright, so plug that in there. Jobs are good, and see what happens. Yeah, looking like their compute drivers for AI and stuff is really cool on like the graphics. We'll try and change that. Yeah. That's what they do, innit? You know, AMD is like too busy like following what Nvidia does and basically making it be like, yeah, Nvidia, you guys are leading the way, right? Instead of like manning up and picking their own direction and be like, no, this is what we need to give our customers. It would be cool if they could find a sort of a direction which was different from Nvidia, that, you know, because they've basically told Nvidia that yes, ray tracing is something that's good. They've told Nvidia that yes, you're right, upscaling was the way to go, you know, and same with the AI stuff as well. I want. I wonder if they could have done something else where they said, right, we're going to make an open, highly parallel platform, right, which is known as this is the GPU, and make it a sort of a thing which could you have more access to, and then people could build, you know, and then they add more capabilities to the hardware, which allows people to build things such as AI, whatevers, or, you know, because Nvidia's doing all this stuff. They recently just launched something new with like AI. I've not really understood it, but like, but I imagine if AMD just made a platform which allowed people just to have full access to it and offered like a good set of like instructions or whatever, maybe people could build some of this stuff in software. But I don't know. But that would have been cool. But instead, they're sort of like confirming that Nvidia is taking the right steps. So I don't know. Yeah. I'm not a fan where graphics is going at the moment, basically. This is my thing. Not a fan of ray tracing hardware, not a fan of upscalers. Not a fan of AI. We're not going to get any pure. They're choosing to focus on other things and increasing the amount of power that you get in the GPU. So I'm not sure if this is a good texture to test, right? But this is the idea, is that rather than getting an average of, like, we've got a, what's a good way to say it? We've got a certain resolution in the texture cache, and the one at the back has been sampled with MIP 0, which is going to make it such that it's going to be incorrect. So here's our texture, is 2000, it's 2K by 2K. And when we sample this one to the back, it's just picking a smaller range than it should actually be doing. And we're not going to get the proper... It's not going to look like a downsampled image would look. Basically. Where it's like an average of everything. So when it's really far away and it's that small, you won't get like an average of the pixels. And yeah, so I wonder. Yeah, so what's the better way of saying it? So when you sample here, it'll be sampling a 2x2 region in a higher resolution texture, which means the sort of the area which it's sampling will be smaller. What's we saying it? The area in screen space will be larger than the texel space area that it'll be sampling from. So we need to select the right MIP level such that it is picking a 2x2 region, which is picking a 2x2 region where the pixels are bigger and mapped to something which is more approximate to the screen space pixel 2x2. So that's what we need to figure out. NVIDIA already have the market share and they, like the fear, they will become obsolete. Sorry. And they fear they will become obsolete as devs won't care as much if they go different. Right. Yeah, but they're just trying a bunch of gimmicks at the moment, you know, AI and frame gen and upscalers. I don't know. Yeah, I'm a bit skeptical about AI, to be honest. I wonder how long it's going to last. I don't think there's going to be a lot of money for it within 5 years. Because I don't know there's going to be enough smart people to actually do anything in 5 years, and people are going to realize what it's good at and what it's not good at, and where the boundary is for it. People are overhyping it at the moment, aren't they? So is this a good... You know, we can move the light. If we move the light, that would help. So it's just a directional light at the moment. So if we get it pointing... Might be pointing far, so that's going down. I've already kind of got one going. You want it to go more far though, isn't it? And what, is that like a blue one? No. I think that'll be right. Okay, maybe not. Ah, so we're really... It's on the other side. Oh, okay. It's because the direction... It might be a direction towards the light. No. Oh, it's the direction which the light is... Yeah, it's the direction towards the light, I think. Yeah, I don't know. We still need to do a second pass on lights. That is definitely a little bit too intense. Let's drop the 10 off it. I think we put it just a little bit further back. So we're looking at... Well, a little bit. Let's put it 100 or something, twice as far. So... Yeah, and I think when we move up to the side, we'll start seeing it sort of play up a bit. Or maybe not, because it's actually a smooth gradient. I think the problem is that this texture is a smooth gradient. So what we're getting is a kind of a smooth result anyway. If we were to put some things in the texture, so I was sampling some noise. So what I could do is like apply that noise to the color. So the noise is like 0 to 1, sorry, -1 to 1. Then I made it 0 to 1. And then like... So, what could we do with this noise? Well, we can use it to like multiply one of the components. I guess. And that will cause it to change. Let's drop the blue out. Maybe that's a bad idea. We'll see what happens. But I think it should change a lot over the surface, and it'll probably look ugly, but that's okay. Right, we're seeing it kind of on the wrong side. So yellow is kind of green and red, isn't it? So really it should go here. And then like, I think the noise... Yeah. Maybe we need to make it a higher frequency. And then that will be... Make it a bit more higher frequency. So times it by 10. We drop that. No. Higher frequency means only to multiply by higher, right? Yeah. We had some odd seams there I saw. What was that from? Excuse me. Alright. Have a good sleep there, Geeko. Good to see you. Thanks for popping by. That's cool. Yeah, so I wonder where that seam... That's just because I've done some wacky, crazy thing based on the UV. Yeah. That's just because I've done a crazy thing based on the UV. And that's fine. The seam is coming because I've done it based on the UV rather than the normal. If I did this noise based on the normal, then we wouldn't get this problem. So if I take the noise and did it as... Oh, excuse me. My days. Yeah, so if it's based on the normal, we won't really get such a seam, I think. So I want to make that more higher frequency or whatever. So if I multiply that by 100, and then let's go back to the graphics and then move that back to probably about 50. Yes, put it back to 50 so we can see more pixels with it. So the detail's going to be a lot more higher. When it's further away, it should be something from the lowest MIP, so it's not going to get... Oh... Too high frequency. Oh yeah, but we're seeing the problem. Excellent. Because of that, that's good. Okay, so here you can see the very high frequency noise. And as we move, see how that background one changes very fast? And it's sort of... So it should be using a lower MIP. And then it should sort of average it out a bit. But you're gonna get those sort of like artifacts like that maybe. I wonder if it would fix it if we selected the right MIP, to be honest. Yeah, so the size of the pixel in screen, or on the surface of the object, basically. The way that maps to the area is not the same as the same size or the right size inside the texture space when you're sampling it. So it's get a 2 by 2 and take, doing the wrong ones. So we want probably... Yes, this MIP here, 2K, is the one you want for this close one here. Well, it's probably... Yeah, it's about 2K. And then the one back there... I don't know, what's the size of that? So that's scene. Oh, what was a bit too high. Yeah, size that, I don't know. But as you can tell, like when you move, it really does change drastically. And the size of that is, so that's about 4 pixels. That's another 4. So that's 16 about here. So if you take that, double it, it's about halfway. So it's 30. So it's 64 pixels. So if you go to the 64 by 6, this MIP here, you should be sampling from this texture here, so you can already see a difference, right? If we go back to the 2.1, you see all this sort of high frequency noise, but when you sample it from that one here, the 64 by 64, that high frequency noise is now gone because it's actually like been averaged out. So when I move and so when I sample over this, it shouldn't have all these sort of like glitches with it, right? That we're seeing, because that information is just not there to be sampled from. Now, so we need to calculate the MIP level. So calculate surface color. We call this, we pass in all these shading parameters. So there's a bunch of input parameters like the direction towards the camera from the surface that we're trying to shade, and then the surface position in world space, surface normal in world space, surface normal in local space, and we pass those in, and with a material index, it does all the sampling, that sort of octahedral map of those every PBR texture, so albedo, emissive strength, meltness, roughness, and then it just outputs a color to shade that pixel. So it's just your classic PBR shading. Now, the thing we've got to work out is this, which is the MIP level. So ideally, we need to be able to pass in the MIP level directly, or we need to pass in the gradient, I guess. Is that what it's called? Yeah, ddx, ddy, so you can get the derivative. ddx, ddy, and it will do it for you. Yeah, so I think we pass in the ddx, dy. So what does that mean? So I guess let's do some drawing. So effectively the way they do it is if you have like a 2x2 set of pixels in a pixel shader, you might have like a sphere like this that you're shading. So each of these have done a ray versus sphere in our case and hit this sphere. Now what it's going to produce is each pixel is going to have a UV. Now what we need to know is how much has that UV changed between the X and the Y axis. Right, so if this pixel was the ddx and ddy, what's the difference? And it'll be the same for all of these, basically. And you can use that information to know. So that we can pass that into MIP, sample MIP gradient. And I think in HLSL it's called sample gradient. Sample grad. and it will do all of the maths from there on out to select the right MIP level. I'm pretty sure that's the way it works. So with that information, you can basically get like the size of the texture and figure out how big is your 2x2. How big is the 2x2 in screen space? And then select the right MIP level where this is at that size. So we could do this because we know the size of the texture maybe, but we could just pass it to sample grad and do it for us. So yeah, again, it's the size of how much the UV changes over a 2x2 pixels in screen space, and then find the appropriate MIP level where what is it again? Yeah, you're finding the appropriate MIP level where you will get basically the nearest 2x2, yeah, a similar sort of size area, if you will. Yeah. So I guess so we're in a compute shader, so we need to calculate this manually as well. This is another reason why we've got to do it. So currently I'm doing this sort of like shading. So another problem you've got is that we could be shading two different ellipsoids for neighboring pixels, basically. Yeah, so for a 2x2 set of pixels, these will be running in lockstep, so the code will be running at the same time. So long as these are shading the same ellipsoid, this will be okay. But when they will shade, if there's another ellipsoid which is in front of this one, then it means that maybe they won't be shading the same ellipsoids in the same sort of, because I think I sort them front to back and then I go over them. So I think currently I've got many different compute shaders. I've got one for like super sampled anti-aliasing, multi-sampled anti-aliasing. I've got a visibility buffer approach as well. And so here's the visibility buffer one. This is the one that we're using at the moment. It's on by default. And with this one, it's probably the easiest, I think. So we need to calculate the derivative somehow. So we won't get the UV here, unfortunately. But you can get the UV based on the surface normal. Right, so actually, rather than passing in the surface normal here, what we should actually be passing is the UV. Oh. Yeah, so you should be doing... Okay. So you take your hit normal in local space and you pack octahedral to get yourself a UV. Now, if you take your DDX, now we don't have DDX in, or do we? Right. So HLSL DDX, doesn't it have that in? So what DDX does is it returns to you the difference between the pixels in your quad. And does this work in compute? Oh, I knew I had some pixel shaders on HLSL. I think I did that for mine as well. But we can do it manually. So quad swap. Now I want to be careful because we could have inactive lanes, and quad only works with active lanes. So that's a bugger. Yep, certainly does. How's it going, Kappa? How have you been? So quad swap X UV. Yeah, we can't do like a quad sub, can we? So I'll just do a swap. Right, so we've got swap, read thread. Okay, so we can make ourselves. So we did a quad swap and do a subtract. Now this is where we've got to be super damn careful. To do a sub there. I think that gets you the DDX. Do you have to do an absolute? Right, let's go back to my DDXs and that. Those pixel intrinsics. So thread 1 take thread 0 and it returns that, right. Yeah, so I guess you do an absolute. Okay. So if you got the 2 pixels and you take them away, you can do an absolute on it, and that might be what you want. Now, so that could be DDX and that could be DDY. The issue is that we've got inactive lanes. This here's an if statement, which means it breaks the code below, because if something is not got an ellipsoid in there, then it will not run this. Yes, if you don't have an ellipsoid at that pixel, it will. You have some inactive lanes here, and quad intrinsics do not work on inactive lanes. So we need to make them active. And yeah, figure that one out. Not bad, how am I? Yeah, I'm doing okay. You know, I went to the gym yesterday. I had a really good time with my wife. She did some running and stuff, and I did a little bit of, I did the elliptical to warm up, and then I did like, you know, just weights and stuff, basically use the machines. It was good. But then I went into the steam room, wasn't going to the, what was it called? The sauna. I was going to go into the sauna, but it was basically full. So I went into the steam room. And when I came out, it felt so amazing. I was just basically all done, worn out, and felt amazing. But then I came home and I was just ill. Got like my nose is playing up. So I caught a cold somewhere along the way. But yeah, it was a good time. Yeah. Have you been up to much lately, Kappa? What have you been doing? Tell me what you've been working on. See, I think we can pass in the UV here now. And then we got to solve the inactive lane problem. So we should be able to let this code run, kind of, right? So to make this code run, all we need is a hit normal in local space. So you do something like this, right? You bring this out here, you initialize it to 0. You run that code there. Oh, it's such a damn problem. No, you bring all of these things out here. And then the thing you got to be careful of is, what do I make the UV if the lane was inactive, basically? Oh, sorry, all we need is UV. But then I need that stuff to come out of here because so shading goes out here, right? They all get filled in there. UV also goes out here. Now, the lanes are active. So you can do the quad intrinsics, right? And then you can put it in there. Calculate the final color like that, okay. So that's the way of solving it in this case. So all of the threads within the quad will be running for definite now, because there's no branches to run this code. Yeah, maybe it could have been that. Or maybe it could have been some of the stuff on the... They're touching some of the equipment. Someone else could have had a cold. No, so you've got steam rooms and saunas. I learned this the other day, I think. So, yeah, saunas are dry heat generated by rocks, electric heaters, or wood burning stoves, while steam rooms are moist heat, so it's like actual like steam, right? Yeah. So I guess it's you know, one's humid, one's not humid. Both ends of the extreme. So you count your derivative here. So then what do you set UV if you don't go into this loop, right? What do you do to UV? Well, UV needs to be maybe, hey, what is my one next to me? Right, so if... Yeah, so I guess what you need to do is set... What you really need to do... So we're doing the subtraction no matter what. But maybe we set it to something invalid. And then... So you can set it to something invalid, do the swap. If it's invalid, set it to what you are. And then that's it, right? Yeah, I guess we'll roll with that. Let's just get it working, and then we can think of other ways to do the derivative. So we'll set it to like infinity. No, I got that as it. Alright. So now we do the swap. And then UVY, yeah? Then you say, right. So DDX would just be... So in that case, it would be 0. But yeah. So I guess you can say if isinf UVX. We'll just try 0 for now. I wonder how that would actually look. And then you say if not use UVX. Oh, yeah. And you do the same thing for the Y. And voila. So I think that... Right, then you've obviously got to pass in the DDX and DDY as well. So the thing is about the UV, why am I setting UV in shading, to be honest? Why don't... because I'm not really passing it around too much. Might as well put material index in there as well, really. I don't know. What DDX, DDY needs to go in? This part, yeah, put more in DDX, DDY. Alright. So, then I'll say shading dot DDX equal DDX and then DDY. Now, we've got to sort out the internals here now. What we can do is instead of using sample MIP level, so if we look for MIP level, we can do sample MIP gradient. Okay, let's do that. Sample MIP gradient. Then at the end, rather than MIP level, we do shading DDX, shading DDY. I wonder if we should have just gone the full way and calculate the MIP level ourselves. Because then you're making it do the same work over and over again, maybe? I don't know. But we'll see. So shading DDX, DDY go into there. Why work? Oh, did I do times 3? It was damn times 3. Why does it want a times 3? Surely that's wrong. Yeah, I need to probably change that. James, watching these streams inspired me to do something. Yeah. I've just been existing. Henry hasn't pursued any personal projects recently. Oh. Ah. Well, no, this is my personal project. I have been pursuing the exact same personal project. This is what I've been pursuing in my time. Because obviously I go to work, isn't it? I go to work Monday to Friday. And this is what I do in my spare time. Got my own little thing. Right, let's take a look at HLSL's sample grad. I don't think I have done mine right. Yeah, so the 2D array should be doing a float too, damn it. Right. So I think I got a code generation for that. Let's fix it up. Yeah. I think there's a... What, scripts? Intrinsics code gen, is that what it is? Yeah. Okay, so in here, when I'm so I just code generate that whole file, just, you know, as you do. So mip gradient. Right, so in this case, I guess I'll say TG, I'll do another one. TCTG. So I'll call this the texture gradient type. Good old code gen. So for gradient 1D, you just want to float. Just want to float for a 1D array as well. 2D array is 2D and 2D array is two-dimensional. Then cube is there a cube? Cube is same as 3D. Cool. And then that'll be it. So that shouldn't change anything with the code. The yeah, so it's made that new texture intrinsics header. So if we go to how's the kid doing? The kid's doing great. He's just actually started to walk now, finally. He's like 1.5 years. And has now got the confidence to actually walk, which is great. So it's a lot of fun just, you know, plonk him down in the middle of the room and he like, you know, does this sort of, you know, super concentrated face of trying to walk and, you know, is doing it by himself, which is great. He's been able to do it. It's just the confidence to do it is lacked very hard. But yeah, it's a lot of fun. Want to try and get another one of those soon. You know, another BAB. Yeah, those guys are dangerous stuff. Yeah, we've got a little baby gate for the stairs. We've only got one at the bottom at the moment because he hasn't seemed to be that interested at the top. But yeah, plus we always keep an eye on him. Reload. There we go. They're two-dimensional now. Job is good. So now run the compiler again. So if this works, we'll commit that. Excuse me. So uv.x, uv.y, we don't do that anymore. Yeah, the UV is passed in via shading. Yes. Great, so now we'll just go to all the other different ray tracers I've written, because you have to test all the things. If not, you will never know, and you'll always question yourself, but was this other way better? So we'll just remove that local space normal one, and later on we'll do the UVs manually for this. And it's going to be hard, I think, but let's just get it working for the easy one first, and then we can do the rest later. So we want to save any of them, isn't it, really? We just need to save the X axis, or whatever, it doesn't matter. Any of the components, if anything. Right, there's no E anymore. So E is the ellipsoid. We'll cache that there. Let's go. Right, so let's hopefully see. The ellipsoid behind shouldn't... Oh crap, the current ellipsoid's got problems. We're seeing seams now. But this seems to be looking alright. We're seeing an average of it now, and we're not seeing a sort of a high frequency thing going on there, which is really cool. Yeah, so I really gotta... Like, if I were just to put 0... Yeah, so every 5 seconds, if I was to make it change to 0... Well, okay, let me hard code 0 in here. And then we can see what the difference is like. Why did I say 0.5? What's a melon? Am I? Let's plop those in there. Quick question. Why do you think Colmac is better for programming? I don't say it's better for programming. It's just a more ergonomic... Or maybe... I'm not sure what I said in my thing below. But... in my about section below. But yeah. It is maybe... What is it about the Colmac keyboard layout? It's a more ergonomic keyboard layout. It's a keyboard layout that's built for computers. So like, in terms of like when you're typing characters on the keyboard, your hands are going less from the bottom row to the top row in very awkward ways, or than they are when you type QWERTY. Everything is centered. Like, I'm not sure how true this is, but I guess it's a good way of sort of explaining it. For crying out loud, get rid of that. So, QWERTY and Dvorak were both made for the typewriter. So these are the sort of the most common keys that you'll press, right? Are these? It's a heat map, right? So you kind of go a lot like up and you go all over the place a lot with QWERTY. What's a good way of saying it? Yeah, so what's a good way of saying about it is you're sort of like you're jumping all over the sort of keyboard to sort of yeah. Lots of top and bottom row action going on. Whereas with the Colmac keyboard layout, a lot of it is kind of around the center. So you might sort of start a word off down on the top and bottom row, but a lot of the in between, lots of the letters that make up a word typically are in the middle row, I think. So it's just a lot more ergonomic. I wouldn't call it like you could probably type ever so slightly faster on a Colmac keyboard, but you could probably just it's probably negligible that to QWERTY is probably more comfortable on a Colmac one, but again, to notice that is kind of difficult because you've got to go back to the QWERTY and try and learn it again. My one thing I would say is if you want to try it out, make sure you still have a QWERTY keyboard that you use regularly, because then you literally will forget the muscle memory, because you'll sort of trade one muscle memory for another one. But I would say this is probably not a thing for you to do if you play video games a lot, or yeah. because yeah, not all games play nice with a different keyboard layout, basically. Yeah, yeah, it's it's absolutely fine. I do it on my because I I work at home. I just roll up about I've got my home PC under my desk, and this is just boots right up into Linux, and it's just in Colmac, so it's fine. Got the Windows PC, which is a work one, and again, turn it on, it defaults to Colmac, and it's fine. I guess the problem is if you use the Colmac thing 90% at home, and then you have to go somewhere else at work, and you have to use the QWERTY keyboard, then you're literally going to be looking down at the keys the whole time because your muscle memory is just going to go. So yeah, just be careful with that. Yeah, you can still like for games you might have to remap if they don't use scan codes and they use key codes. You have to remap it. So you can do it. It's just fiddly if you play a game. You might have to yeah, do it, unfortunately. But yeah, so I guess what's the what we're trying to look at? Oh yeah, so if we made this bigger, yeah, so you can see how this sort of we're seeing this sort of very high frequency noise detail here. We're seeing it cause a problem in the background because we're using the same MIP level as the one here. Right, we're not seeing a sort of an averaged version of it. Now we put in the right DDX DDY. Now we've got a bit of a seam problem, but when we move backwards and forwards, we don't have that issue anymore, right? Because, and I'll show this one more time. When we look in the texture viewer, did I nudge my audio cable? No, we're fine, good. So what we see in the texture viewer, so the one at close range is probably this 2K resolution here. So when you sample a 2x2 in here, you're getting like this very high frequency detail. Now, the one at the further back, no, the one at the back here is probably about 64 by 64 pixels. So, yeah. So if you keep a look at this detail here, watch how this high frequency detail goes away, because we'll be sampling from this instead. So it would have averaged that result, and therefore we won't get the screen pixels that we're sampling from would have the area, would have the correct sort of area of a 2x2 on screen and in texel space. So we won't be getting this detail like a small 2x2 in here. Instead we'll be getting a proper average of the whole area of those 2x2s, right? And so when you move backwards and forwards, you're not getting that high frequency detail sort of like show up anymore, which is great, right? So now the problem is what this damn seam. So this seam, right? It seems like the seam is part of the octahedral mapping thing again. So the problem is the derivative. So we've got to get, so it's a mirrored repeat sampler we're using. So we've got to, we might have to do a sort of a mirrored repeat thing on the UV, maybe. And a simple sub might not be enough. Yeah, it's linear. It's bilinear interpolation. So it's a two-dimensional linear interpolation. So it goes across the xy. So it's like this, right? You got 4 points, so 4 centers of 4 different pixels, and you've got a sample point in between them, and you're getting an in between of all those. Yeah, so it's bilinear, two-dimensional. So we've got a seam, which means the way we calculate this derivative is now wrong on the seam. So where would one... So the problem is you've got a... Yeah, it was a real problem. We can bring up the... We'll bring up the... So we take the albedo. Hang on a minute. Right, this would be a good way to visualize it. Ooh, so I'm just changing the material. Well, one can dream that's the best way to visualize it. What did I do wrong? Oh, times by noise. Okay, so there we go. So we open this up in the texture viewer. So here's the octahedral map. Ta-da! So this is a problem I was fixing earlier, was the seam. We had a seam. Oh, still a damn seam. Oh yeah, sorry, that seam is from the derivative thing now. Yeah. So yeah, so the problem is with the octahedral mapping is if I was to go across, move my mouse across here and here, right, this edge, you would think, right, it's going across here and wrapping around to here. But the way the octahedral mapping code works, the way it maps a normal from the sphere's surface to this octahedral texture is actually going across here like this is actually something like this. It goes down like that, and then it reappears over here, like over here, right? So that, and then like that. So the way we solved the problem was we used the mirrored repeat sampler. So when you had something near the edge, it would basically duplicate this pixel on the other side. And so when you just get your same pixel basically back when you did bilinear interpolation. Now the problem is when is now different. The problem is we've got a pixel coordinate here, and then in the neighboring pixel next door, we've got a pixel coordinate over here. So now the derivative for this ddx it would be so big that it causes you to sample from a different MIP. And you get a seam, I think, right? You always see the seam. That is always there. So you're basically sampling from the lowest MIP. You're getting like an average, I think. Yes, here's what the average looks like. So you'll just get something like that, right? You know, you start to see more purples here. In this case. So what's the fix? I don't know, we want to figure it out. This is the fun. Is there sort of reason why using this mapping, it looks like a pain in the butt to do with the edges? Yeah, so the reason is because I get to map a normal. So there's a single texture. So the easiest method would be to use a cube map. But then I got 6 faces. If I use this one, I only have one face, or one layer, one slice for the whole sphere. So when we generate materials, all we have to do is make sure we encode it into this projection mapping thing, whatever you want to call it, this texture mapping, and then it should 2 seconds. Yeah, then it should be all right. But yeah, so the cube map, I don't know how you generate the UV, sorry, the MIP from that. Yeah, could you use the normal? Can you get a derivative? Because we have the normal, right? So I wonder, could you somehow produce a DDX from normal, maybe? Would be interesting. Is that even a thing? Because you got to get the pixel and take. You probably got to know the size of the. I wonder if you could use the normal. Is it a problem for spheres? I don't know. Is it a problem only for spheres? Well, it's probably a problem for a lot of things. It's like, you know, how do you map? You know, how do you map it down into the, you know, it's UV mapping in general. Right, there's always going to be a seam somewhere, and you've got to like where you put the seam and unwrap your texture. There's a bit of an art to it. I'm not sure exactly, but yeah, this particular problem is probably to do with just the way we've started to use the octahedral mapping for the sphere. So the problem comes from when we calculate the derivative, it's just obviously very distant when it isn't. So maybe we should calculate the derivative in normal space instead, right? Just using the normal, but I don't know how you'd do that. Oh. Yeah, it would. Wait. So if you took the difference of the normals instead, let's have a bit of a. So if you took the difference between the normals instead, so that's three-dimensional. So and then you took that result and then convert that into a UV, but that's not going to get you anything. Because that's still just going to map it into... That doesn't get you the DDX or DDY. You see, I wonder if you could find... If you take the difference between the normals and orientate it in such a way where... where it would line up at 0, 0, 0 in the texture, then no, it wouldn't really work, will it? No, you can't. But yeah, I wonder if you could calculate a DDX without going into the octahedral. Difference based on the normal. I wonder if people have done that. Because for a cube map, you would... We've done this in the shader... Yeah. So for the texture viewer, when we take a copy of the texture at a certain point in the frame time, for the cube, we've taken a... We've taken a... Right, so normal shooting directly up would be in the middle basically, so it's like taking away the half dim from the coordinate. And so yeah, so we're figuring out for a pixel how do we make a normal. Right. But it normalizes it. So it's not very trivial. So it's like a direction. So it's a whole vector going towards a pixel and then we normalize it. Okay. Right. So I wonder if we could use... So in a sense, you could say we've got a bunch of pixels kind of going towards a... Sorry, a bunch of normals going towards a bunch of you know, 4 normals going towards 4 probably different pixels where it's a location within a texture, right? And kind of in between pixels. If you take the... Yeah, I wonder how people would do the DDX CDY of a cube map. Let's see. Yeah, so they're doing the actual... reflect ray. Oh, and they use the DD. Oh, and because they're doing a sample cube, they're able to. Right, and it would do it for them basically. Interesting. So I wonder what the maths is behind sample grad. Oh, someone's done it maybe. How does the seam always default to black if the sampling from a different bitmap each time you cross the boundary in? Oh, 2 secs. I'm gonna sneeze. Right, so your question is like about this seam. Like it ends up just yeah, I'm not sure. It's just getting lucky. I'm not sure exactly. Maybe it's like the MIP level. I'm not sure what MIP it gets, but it's probably the one all the way down low here somewhere. Yeah, it could just be getting lucky with this one, but it might end up just going purple or something, doesn't it? Maybe it's going all the way down to 1. Oh, it's kind of grey looking, maybe. There, obviously. Yeah, maybe it's fading that grey one, thinking about it. And then, like, it just so happens that the DDX, DDY there is not 0. Yeah, is not 0. And so it's not getting that very low res. Would it be 0? I'm not sure. Oh yeah, 0. It will put 0 in, but wait, it won't get infinity. Sorry, it's just very large, isn't it? Yeah, so it'll get a very high DDX DDY, which will then cause it to pick the very low resolution MIP. And it just happens to get lucky that it doesn't do that. It's not quite the edge or something, I don't know. It's what I think it would be. Yeah, so this sort of person has manually calculated a LOD for a cube map. So he's taken the sort of the reflection rates of the normal, and then dyr. So it's the derivative of these passing into this get diff cube. So it will get a cube coordinate. That's looking a little bit crazy. But yeah, it's figuring out basically the pixel, and it's doing it. So there's the difference for the vector. Then doing it for the difference. Well, then calculating a new derivative for the pixel in UV space or something like that. So yeah, it's possible you could do it based on a cube map. Right, so we could probably do the same thing again, but for the octahedral maybe, but that gets a bit... So you got two UVs. Now we just need to know, are they close to each other? Yeah, I wonder how you solve that. I wonder if we Google for our actual problem, if someone solved it. So octahedral mapping derivative. That would be the right thing to Google for. Ray tracing gems, eh? People. Right, what is this thing saying, eh? Octahedral concentric uniform map. This is a branchless way. Says the latitude longitude. The previous method, latitude longitude is intuitive, but the drawback is that it stretches when sampling the domain quite significantly at the top and bottom, the poles. Building in the concentric map and combining with the octahedral map, it's possible to define octahedral centric mapping. With two good properties, its stretching is at worst a factor of 2 to 1 with the uniform two-dimensional point as input. Gauss transform to unit spheres as follows. So, sampling directions. See, I wonder how if they bump into this problem. So sampling PDFs. What's a PDF mean? Partial derivative. Differential function. Right. This is exactly what we need. Think so. Right, so it's down here. To find over directions on a sphere or hemisphere is a central part of many ray tracers. Often the sampling is integrated. Let me not heat up my computer more than I have to. Often this sampling is integrated incoming light to compute the outgoing intensity at a point. These PDFs are commonly defined in spherical coordinates. The polar angle, sometimes called the zenith angle, denoted as probability distribution density function. Right. Okay. Right. Yeah, that's something different. Yes, this is to do with actually the lighting and the PBR model. But I wonder if... Right, I see DDX here. If primary surface visibility is rasterized and the G buffer can be used to compute the surface spread angle, this approach that can be taken here, though there are likely other methods that could work. The normal n and the position of p in the fragment are stored in world space. We can use ddx and ddy to obtain the... Yeah, but that's not to do with... That's to do with something else. Right, what about the MIP? Yes, I think this was... Maybe references it here. What section is this? Yes, the sampling at... Okay. This maybe has some answers in here. Which probabilities though? Well, it's PBR, right? So with PBR, it's statistically based. Like, it's to do with like, from understanding, or what I think it is talking about is basically like a rough surface. It's like how many, when a surface isn't perfectly flat, it's got a bunch of like little, it's kind of rough, isn't it? And it's like how many of those sort of surfaces are pointing towards the camera, and that's the probability that you're working out. And that's what that's talking about, I think. So I think this code here is talking about... Oh, maybe it is doing that calculating MIP because it says sample level. And it's saying using MIP 0, so I'm assuming this is... We've implemented the ray cones and ray differentials techniques on top of whatever. For texture lookups in ray cones, we compute whatever that is according to these two equations and feed that into sample level. Right. What are these guys talking about? 34 Amadeus. Okay. Since rasterization is highly optimized for rendering primary visibility, where all rays are shared in the same origin, we use the G buffer pass for ray cones. Whereas there's a sort of like cone ray tracing thing that they're doing, but I don't think this is going to be beneficial for us. So there's a bunch of different ones. There's a sort of ground truth, MIP0 ray cones. Compute texture LOD, ray, surface hit, cone. So I wonder if you could... So the cone is defined by width, spread and angle. But then, how would that... Yeah, think of it as a surface being made of a bunch of tiny mirrors. The PDF would present the probability of the orientation of those mirrors over that unit hemisphere. Yep, that sounds familiar. Cone. Texture width, texture height. But then how do you know? Right, so it's the height log 2. Ray direction, surface normal in world space. ABS log 2. Triangle LOD constant, not sure what that means. It's probably some kind of offset or something. But yeah, so maybe we do something like this approach to calculate the LOD based on the width of the cone. Like, I wonder if we could, like, if we've got like 4 pixels, could use that to define the cone, I wonder. Because compute cone from G buffer, right? So spread, I'm expecting to see this function declared somewhere, but I cannot. Right, equation 30. $31, $30. Okay, that's not too hard, is it? Just got to figure out what these inputs are. So that would be, see if I can understand it. In this subsection, we represent a single method to compute the spread angle of alpha of a pixel, i.e. for primary rays. So primary rays are things which go through the pixels, right? The screen pixels, which is what we're doing. That angle from the camera to the pixel varies over the screen, but we have chosen to use a single value as an approximation for all pixels. We trade a bit of accuracy for faster computation. The angle A is computed as, so arctan with 2 times tan of whatever that thing is. I forgot what it's called, but whatever this symbol is the vertical field of view. And page is the height of the image in pixels. Huh? Yeah, so that's just giving you the, yeah, I've done that calculation before many times. So you're not passing in anything here. So what's pixel? That just sounds pretty constant to me. I don't understand. Our equation 30. There's no input. A is the output. This is the vertical field of view, and h is the height of the whole image in pixels. Maybe passing the... I wonder if there's a complete example of this somewhere else. But yeah, that doesn't... But yeah, we could probably produce some kind of spread angle. What is a spread angle then? What is a width? What would that be defined as? So where's the cone? Oh, it's very easy to Google for. Oh, sorry, search for, isn't it? Search for cone. Might be a better place to start. Okay, so I wonder if... Describe how array cones can be used to access the MIP level hierarchy in an environment map. Array cone can be described as a width. A width W and a spread angle Y. See chapter 20. Not interested in that. Oh, spread angle. Right, so where's spread angle in here? Oh. 20.3 maybe. Right. A... Right, pixel... Where would you say there's a spread angle? Let's scroll back up here and write spread. Okay, the footprint angle, also called spread angle, of a pixel is called A, D0. Is the vector from the camera to the hit point. The cone is tracked through. So is spread angle just the vector towards the just the vector? So when we saw that down at the bottom, down here somewhere, that was no, it's a float. Right, so run out loud. So I wonder if there's an implementation of this in Shader Toy somewhere. What is it? A cone? What would be called? It would be called something like cone. Cone texturality or something like that. I just want to know how it avoids the boundary issues. Well, because you're not doing it right. So if you're doing it in this sort of like cone space, you're doing it with the normal, right? And the boundary issues only comes from doing it in calculating the differential in texture space, right? So if we're just using this hit normal, all right, that if you take that sphere, those boundaries don't exist because you're sort of the normal is a linear, like it is continuous. You know what I mean? Whereas if like the value going round to the other face is continuous. Whereas if you go into the octahedral mapping, the value when you go round that face ends up being discontinuous, right? It ends up jumping to the other side of the texture. And that's where the boundary problem's coming from. Oh, not boundary. Oh, that's where the seam is coming from, right? Because the MIP ends up being absolutely huge, right? So what am I looking at? Cone mapping demo. What is this? Looks cool, but I don't know what it is. Choose rays in a sphere. Find the average unoccluded direction. Shoot rays. I don't know if this is what we're doing. It's the actual map that it's generating. But I wonder, do they have cone direction, cone angle? That's how they define their cone. As you would expect a cone to be defined. But yeah, I wonder if they use any sort of like... What do they call it? It's sample, anyway. What do they call it? That's voxel cone tracing, that's a different thing. What do you call like a cone? Differential cone tracing for polygons for better. So cone tracing is that thing when you have voxels and you're sort of like, yeah, it's a different thing maybe. Let's see. We had the partial contribution of alpha. Yes, the cone tracing is a way to sort of like early out, I think, when you sort of like trace against voxels. But then also, it could also mean array marcher, sphere marching as well, probably. So, yeah, we could probably just be getting a lot of sphere marching, array marching things, really. So we're back to that code. It took the cone width. Oh, all it needed was the cone width. Ow, what is that? triangle area. Oh my days. The area of the texture coordinates. Yeah, this is a bit hairy. Area of the texture coordinates. Yeah, I wonder if we could just search for. Right, IQ's got some stuff here. Yeah, but is it doing it rain marching? Let's see. 2015. So 10 years old. Alright. The solution is easy. Since hardware cannot compute correct temperatures for all cases, let's do it ourselves. In the case of a classic ray marcher, at the time we're constructing our pixel array, we can also compute rays going through the two neighbor pixels, that to the right and above or below the current one. The difference between the two ray directions and these two extra rays are called ray differentials. They basically encode a footprint of our pixel in world space, its size and orientation. Then, as we ray march and traverse the scene, the difference becomes larger and proportional to the traveled distance, quite like a cone tracer. So as you keep these ray differentials around, we'll be able to estimate the footprint of a pixel being rendered at the intersection point in world space, then estimate the texture coordinates at the corners of this pixel footprint to tell us how many texels we'll need to consider for proper filtering. Yeah, so you can do a thing where you sort of get the pixel size at unit where the camera is, and then sort of like, or the near plane is, then multiply it out, right, to the depth basically. But I wonder if that's what it's doing. So you get the surface hit position, get the normal, texture mapping. Let's assume we're like classic, oversimplified. Yeah. That's not solving the problem anyway. As I said, the problem both T and OID, object ID, are discontiguous at many pixels. Yeah. So if you have a different object ID, even with the same object. Yeah, because you could step really far. So you could be looking at a very long object, and you could have one pixel which is here and one pixel which is up there, and there's a lot of. Is that what you would get? No. You would just get how do we distinguish in the same object? Oh, they're talking about T. Oh, so they're talking about the hit T and object ID, right? Hence, everything downstream is computations of, or is discontinuous too. Position, normal, and the coordinates UV. Right, okay, so they're saying these are discontinuous. So all the stuff that comes from them are going to be discontinuous as well. The proposed solution is to approximate the surface of the object OID and the plane tangent, right, to it at the position of the intersection, given the normal that we have. Then we take the two rays passing through the neighboring pixels, intersect them analytically with this tangent plane. Right. I see. This is very cheap, free compared to expensive ray marching we just performed. The difference in the intersection points will give us the pixel world space footprint. Right, that makes a lot of sense. We take the two rays passing through the neighboring pixels and intersect them. Yeah, so basically, from what I understand, they could probably find an image for it. Yeah, so say if we hit this point here, there'll be a pixel that's like that it's sampling, and it's in, you get that tangent plane, so the plane that just sort of sits on that surface, and then those neighboring pixels that sort of hit a slightly different point on the sphere, where do they hit this tangent plane for that pixel, and then get the differentiable on that. So I think that makes a lot more, that should be quite easy to do apparently. So calculate dp okay. So ray direction, ray origin, right? Calculate ray direction for the neighboring pixel, okay? Then you do your, you get your hit basically. And then it's saying calculate this, okay? And then your texture mapping. What's texture mapping do? Does this give me DDX? I think this gives me DDX DDY. And what though? Hasn't changed a lot. We first compute the neighbors pixels and then we perform a regular. So what sounds great about this is that it will work on any it should work on any. It's going to add a little bit more computation, but it will work on any of my ray tracers without relying on what the neighbor's value was. Instead, we just do a bit of an extra ray versus plane type of thing, which is very cheap. That's clever. Yeah, that should be alright. Right, that hasn't changed a lot. First we compute the neighboring rays, then we perform a regular ray march as usual, then we compute the intersection of the neighboring rays and the planar approximation of the scene at the current intersection point, a plane that passes through it and its tangent to the surface, and lastly we compute the difference in wall space positions between these intersections and the actual intersection found for this ray. So it seems like it does it in world space, which means yeah, once we have the differences in world space, we need to propagate them through into texture coordinates. This can be done with the chain rule. for planar, run out loud. Skipping over the texture function as I said, blah 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 blah. So there's your world space ones. Using basic trainer planar mapping. Right, he's got it running in a sort of a live ray tracer. This is one more comparison behavior versus the correct one in this article. Okay. Oh, that's a dinosaur. So there's that code for yeah, so here's that function. That calculates the world space derivatives. Then he takes those. He's hard coded it. Just a little bit. Just a little bit slow. It's not bad. Like, it's going to produce better results. Like, my way has a problem. This way seems like it'd be fine. Seems pretty cheap as well. It's a few dot products. It's 4 dot products and 2 divides. A couple of multipliers, and then that calculating redirection, you just do that once earlier on. It's not that bad. It's pretty cheap. It's cheaper than memory fetches, so it should be fine. But yeah, I don't think we'll be bottlenecked by this in any way. So let's look at this chain rule thing. Oh crap. All right, let's read this bit in better detail. So, skipped over that texture mapping function. As I said, whatever transform you apply to your world object intersection position in order to deduce texture coordinates, a related transform would need to be applied to the position derivatives in order to compute the texture coordinate derivatives. A bit of calculus will help you here. And if you are into Jacobians, this will be an easy ride for you. But in general, the chain rule will serve you well as case by case homework to do though. But in the case of planar projection, the results are very easy. If you are texture mapping your objects with vertical projection of the form, I don't understand where the times 0.3 or whatever come from. But yeah, I guess it's saying that is if it's a planar one, then it's pretty straightforward. You just use the same thing he was multiplying it by. But so what he's saying is see if I can understand this chain rule thing. In calculus, a chain rule is a formula that expresses the derivative of a composition of two differentiable functions. And in terms of derivatives f and g, more precisely h equals f, whatever this is, and g, the function is such. Right. Right, I have to look into that a bit more, but yeah, so you just have to somehow get this sort of world space to texture space transform. So we've got a difference in world space then at this point. So we could transform that into the local space of the object and then map that. Could you map it into UV? No, what would that? You could take the height of the, it's in world space, you could bring it back into screen. No. So if you can get into the local space of the object, yeah. Let's see a picture. So if you're doing this octahedral mapping and say if you somehow get a difference of, well, what are you getting? The difference between, it's a difference in world space, surface hits, a rough one, based on a sort of the tangent plane and getting just the difference between them. So if you had that, then you go back to this sort of the local space of the, you go back to the local space of the ellipsoid, which is a sphere, because it's a unit sphere in local space, right? With a radius of 1 or something like that. Then you will have 2 hit points, or sorry, you would have a sort of a, you could probably say starting off from here, you have like a vector going toward, you know, you have a kind of a position on the, Well, you would not be moving back a position, you'll be moving back a vector, isn't it, basically? Hmm. So you could probably say, yeah, I wonder, right? Got some ideas. When you take a look at this sphere head on, what do you see with that sort of octahedral mapping? Well, what you see is kind of those four triangles, right? I wonder if you can do some rough thing with this. So if you put a quad there, just imagine there's a quad there. You've got a vector in the local space of the object. You've got a vector in the local space of the object, which represents the difference in world space. The difference in world space vector, you've got it back into local space, and you got that difference encoded as a vector. Now imagine if you have a quad which just goes there, right? And all you're saying is that difference vector in world space, find the plane which it goes along the most. So there's like 3 planes because it's 3D. And so it's like triplanar kind of thing. Then like trying to planar mapping maybe, and then you pick that longest one and use that as the sort of derivative. Sorry. Then map that, yeah, use that as the UV derivative, because you'd be in what you'd be in -1 to 1 space. Maybe turn it into from signed norm to unsigned norm, and then that might do it. It's a bit of a hack, but maybe that'll do it. But you'd need a transform, which we already have, right? Hang on a minute. Let's find the one was that. It was shade. All right. So you have the world. Yeah. So in the ellipsoid, you have the ellipsoid from world. So you just have to multiply it as a vector into that, and then do that sort of triplanar thingy that was thinking about, and it might just work. Which we'll find out. So I guess let me write this down. So we want to do this thing, right? Which is basically just like, so I'll do that thing. So ray direction, we need that in world space, right? We do. So we need a few of these guys for the neighboring ones. So you'll do one of these like this. All right. And then you'll do a Y one like that. So that'll be your which is not too bad to compute at the start, right? And then you do your thing you call this guy, which we've got to still translate over, but it should be quite easy. Then yeah, we can, let me just undo all this because it's just quite bananas what we've done. So we'll somehow work out ddx, ddy. So that will be, you know, maybe we can get this to work automatically. Yeah, maybe we could pass some of this stuff in to the calculate surface color function and get it to happen always, because I've got a few different ray tracers. Yeah, we'll basically call this guy, and this will give us the oh, excuse me. This will give us the ray, the differential hit, the difference of the surface positions in world space. So we need to calculate that. So what is that? As a 2 vector 3s. We'll get that somehow. dp dx, dp dy. Then we want to move dp dx slash y into local space. So it'd be like a mol v matrix 3D dp dy. And then you want to take the biggest, so it'd be a 3D vector that's going across. It's going, you want to find the plane. So I think it's like, is that called triplanar mapping? Where you're basically finding the sort of the largest. What the hell am I looking at? There we go. No. Yeah, triplanar mapping. Basically, I think you pick the direction in which it's going across the most, I think. I think it was something like that. Maybe I'm misremembering it. Okay, maybe not. So we're basically saying, like, find one of there's three planes. We'll call this dp dx slash y underscore local space. Take the local space and find the plane. Is that right? Yeah, find the plane that it goes across the most. Hmm. So the thing is, you're going to get a different. So you've got like a sphere, and you've got this sort of like ray that hits there. You've got this sort of plane. You've got this sort of difference of the pixels on, right? And the neighboring one, and so on, right? Now, if you just have your planes like this, you got this sort of difference vector, and you're finding the most that it's gone down on one of these planes, and then like why not just use this as the plane, right? So why don't we instead just shrink it down? Then what you want to know is like, yeah, why don't we use that tangent plane? So all we have to do is shrink it. Shrink it down and orientate it into the space, into that tangent space, and take the XY kind of, the XY of it, something like that, yeah. I wonder how we would achieve that. It'd be super rough though, because we're taking one plane and using that to calculate the MIP level for this sort of whole sphere. Maybe we can just half it or times it by 2, something like that. Yeah, so we take that. So you got that tangent plane, and it will be kind of an ellipsoid at this point. But yeah, that will go into the local space of the object, maybe. That vector. And you already, when you have that vector, you already kind of implicitly have the plane, right? You already implicitly have the plane, I think. No, you don't. You need 2 vectors. So you take the surface normal as well. So you got that difference vector and the normal. You take those into the local space of the object. Then you take, right, that can be used to define this plane, I think. You'll need the camera up vector as well, I think. Yeah, okay, so you take the camera ray. So by normal, I meant camera ray. You take the camera up. Then, yeah, okay. So you take the camera, so you take the ray direction, and so you already got that, right? You also need the up vector as well in so that defines the plane at least. You can do it like 2. No, sorry, you need the camera right. You need the ray. You need the view or the camera up and camera right in the local space of the sphere. And then somehow you need to take those two. That's kind of, is that kind of a matrix in and of itself? Yeah, then you do the cross product, and then you've got yourself a matrix. And then you could probably just multiply it. It will be flat though. Yeah, okay, you could do the sort of like, then you take the local space, whatever, and then calculate. So you'll have essentially like this sort of like plane, which is this guy, with a sort of vector going like that. And you can use that to be the, so you have it as sort of an XY value. So you're now taking that into that sort of like tangent space. I wonder if you can just go straight into tangent space though, but then you don't get it. Yeah, it doesn't squish up when it goes back into the sphere. Yeah, okay, so then we'll do it this way. So then take the local space ddx ddy, and calculate the sort of tangent and move it into the tangent space orientated with camera up and camera right. Yeah. And then we can use that. Then we can use that. Use those as ddx and ddy, hopefully. I think that's what we'll end up doing. That's fiddly. But it shouldn't be too bad. So the bit that I'm concerned about is like, so you've got this new plane which is defined by camera up and camera right. We might have to normalize them. Then that will so that this will be the sort of length of the whole sphere. So when you have that octahedral map, that whole 2D texture, that 2D texture maps to the whole sphere. So when you have something that goes like that, that is 4 faces. That fit half of the, yes, you might have to like multiply 2 or half this or whatever. Yeah, do something like that to maybe correct that rough. Yeah. Okay. Yeah, so we're basically roughly mapping a unit sphere, which is what the ellipsoid will turn back into in local space. It's just unit sphere. We're taking that and then a rough guess based on a plane, which just, you know, goes through the center of the sphere or whatever you can imagine it. And how does that, you know, a vector in that space map, you know, map to a vector in that space is sort of like X and Y, how does that roughly map to a texture the same size? Sorry, what's the way of saying it? Yeah, imagine if this plane is that texture basically. We might have to times it by 2 and multiply it by half. Yeah. That should be good. It shouldn't be too computationally heavy as well. I think it should be quite cheap. We're going to try that out next time, guys, on Tuesday. And get a proper MIP level calculation which work on all the different ray tracers that we've got. So that'll be really good. I'm happy about that one. So Thursday will be probably actually working on trying to generate a kind of like a volcanic ground lava texture purely in shader code. And that will be our first sort of test of like what could we generate from just purely shaders, and with like, you know, with this octahedral mapping for all the MIP levels being generated, and you know, even try out stuff like albedo, emissive, and metalness and roughness, and just see what sort of that looks like as a, you know, we'll try and make a really nice quality material. And how does that look close up? How does it look far away? How does it behave with the camera, with this whole thing? And maybe we'll try and generate another one as well. Maybe we should try and generate something non-metal and something metal, just to see what that looks like. But yeah. Right, so let's find someone to raid in the meantime. If you have a good start to your work week, guys, I'm going to go and get some food. Gonna enjoy some dinner. And yeah, I'll hopefully see you all on Tuesday. There's a Discord if you want to come hang out in the meantime. Talk about programming or anything related as such. Right, it's been a while since I've seen Dan's stream. It's right, Dan. So yeah, there's a Discord if you want to hang out in the meantime. Thank you for all the supporters. You guys get access to the code. It's available for people who support the stream. And yeah. Right, I'll see you all in a future one. All right, bye-bye.